So, as a similar problem, we are going to have a deuteron of kinetic energy 50 kilo electron volt comes in moves in a circle of radius 0.5 meter in a plane perpendicular to the direction of magnetic field. What is the kinetic energy of a proton that describes a radius of 0.5 meter in the same magnetic field? That means radius of the deuteron equal to radius of the proton. So what is the kinetic energy of the question is what is the kinetic energy of the proton is asked. So these two radius are same, their kinetic energies, you are supposed to find the kinetic energy. So let us go through the formula we worked out for radius. Radius is either mv by bq or root over 2m into kinetic energy by bq. So here they gave the information about the charge and radius, but they wanted to find out the kinetic energy. So we can make use of this relation. They say radius of the deuteron is equal to radius of the proton. So let us write this equation for deuteron and proton. So radius is root over 2mk by bq. So radius of the deuteron is root over 2m into mass of the deuteron by kinetic energy of the deuteron divided by b into charge of the deuteron, which is also equal to radius of the proton root over 2 into mass of the proton into kinetic energy of the proton by b, because in the same magnetic field, into charge of the proton. So deuteron and proton, as we already discussed, deuteron is one proton, one neutron, and proton is only one proton. So mass of the deuteron is 2 times mass of the proton, whereas charge of the proton E means charge of the deuteron is also E. We discussed earlier. Hence, what are things that are getting cancelled here? So charge of the deuteron is equal to charge of the proton. They both moving in the same magnetic field. 2 and 2 will be cancelled. So what do we get here? Root over mass of the deuteron into kinetic energy of the deuteron equal to root over mass of the proton into kinetic energy of the proton. When you square it, so mass of the deuteron, kinetic energy of the deuteron equal to mass of the proton, kinetic energy of the proton. But mass of the deuteron is 2 times the mass of the kinetic energy of the proton. So let me write here mass of the deuteron is 2 times mass of the proton. So mass of the proton can be cancelled. Here they have asked us to find out the kinetic energy of the proton. So kinetic energy of the proton is 2 times kinetic energy of the deuteron. They said kinetic energy of the deuteron is 50 kilo electron volt. So 2 into 50 kilo electron volt is the kinetic energy of the proton, which is 100 kilo electron volt. So like that information about the radii will help us solve a lot of questions related to that.